So this is probably the last test I'm going to do with the external motor approach. So this is, I swapped the other one out. This is a 3/4 horsepower output motor. I changed the sheave here to be smaller, hopefully get more RPMs out. And I added a couple, well, I had to change the capacitors to make the power factor work with this motor to make it closer to 1. Problem is these heat up. They get pretty warm after a while, so I don't like that. Okay, so this meter is going to show, just again, this meter is going to show the readings going into the motor. Voltage, current, power factor, watts, in real power watts. Well, it's just the power that's being drawn. And then this represents the top pair of coils. So there's 5 pairs altogether. This set of coils here, and then there's one here, and then one down here, and then so on and so forth. This is a current meter scope probe attached to the this light here, this lamp. So when I turn this on, we'll be able to see the current going through here, whether it's smooth and it should line up with the voltage that's going to appear on the scope here. The voltage will be coming out of the same coil. This one here, that represents this one here. We'll also see the frequency, and the frequency will indicate the RPM. So whatever this says, we divide by 16 and multiply by 60, and that should give the RPM. And that's about it. It's a little hard to see the numbers on the camera because there's like a diffuser screen or something, on a protective screen on each of these meters, so it makes it a little hard to see the numbers, but I'll read them out. Okay, so it's 80 hertz here. About 20 volts peak to peak. We got at the moment here saying 0.92 power factor, so it's almost completely real power, so 695 watts. 6.914 amps. And all these panels are reading about 20 volts, give or take a volt. That means the capacitors are all charged up with DC up to a peak of 20 volts. I'm going to see if I can just speed this up a little bit more by putting a bit of pressure on the belt here. So I just press it down a little bit here, and it makes Makes it spin faster, but it also draws more power. So all the panels are going up here, 26 volts, 24 volts, 25, 27, 25 volts. And it's now 91 hertz there on the coil. So I'm gonna turn these on here in a sec. Okay, so it's 800 watts, 0.95 power factor, 7.9 amps. So I'll start turning these on, we'll see what happens. Yeah, anyway, it's not showing up too much the current here. Anyway, 1.74 amps, 21 volts. Power is 784 watts. Frequency is 82 hertz, so it hasn't changed. So I'm gonna turn on another one here. Turn them all on, see what happens. So we're pulling 800 watts, 792, 800 watts, 7.7 amps. This is 14 volts, 1.4 amps, 13 volts, 1.3 amps, 12 volts, 1.2 amps, 13 volts, 1.33 amps, 11 volts, 1.24 volts. 750 watts on the motor. Frequency is 43 hertz, so it slows down quite a bit. Back up to 88 hertz. $800 watts, 7.6 amps, 0.96 power factor. So that's about what it's actually drawing. Real power. .24 volts here. It's 22 volts, 1.75 amps, so power is this times that. Now it's reading 785 watts, 7.5 amps. So it's almost like it's drawing a little bit less power, interestingly. If I turn that off. .84 hertz. Okay, now it's saying 752 watts. Let me turn this on again. Goes down to 80 hertz. Slows down a little bit. 78 hertz. 750 watts. 7.17 amps. So this is 18.7 volts, 1.61 amps. Power is 700. Oh, turn it off. I blew up a capacitor.